Very good morning, students. Today we are going to learn differentiation rules. Next topic is differentiation rules. So, first we will learn about sum rule. So, sum rule is that let us assume that two functions u plus v. So, if I want to apply for this u plus v derivative, d by dx of u plus v can be written as differentiation of the first variable plus differentiation of the second function d by dx. Next, product rule. So which is uv. So this can be written as d by dx of uv can be written as first function as it is derivative of the second function dv by dx plus second function as it is derivative of the first function du by dx. Next we have quotient rule. So that is u by v. So derivative of u by v. First denominator as it is function and derivative of the numerator minus numerator as it is derivative of the denominator divided by v plus. Next chain rule. So d by dx of f of g of x, f of g of x can be written as f dash of g of x into g dash of x. So these are the four rules. Now let us see the derivatives of some basic elements. So basic elementary functions. Basic elementary functions. So first one is constant function. So let us derive this answer by using the first principle. So what will be the derivative of a constant function? Let any variable, let us suppose it is a. So what will be the derivative of this? That we are going to find out. So let y is equal to whatever we can consider f of x is equal to k. I am taking the constant function as k. So we know that we need to find out x plus h minus f of x. So in place of x substitute h, so it will be k plus h minus f of x, which is k. So k gets cancelled, it will be h. So we know that derivative that is dy by dx or f dash of x is generated as limit h tends to 0 f of x plus h minus f of x divided by h is equal to limit h tends to 0. Instead of f of x plus h minus f of x, we can write it as h divided by h. So the answer is 1. So the derivative of any constant function, it will be 1. Next, let us see the next function. Second, elementary. Okay, let us see the exponential function. Let us take anything like x power n, y is equal to. So that is the exact function. Let us find the derivative for that by using the first principle. So let f of x is equal to x power n. So we need to find out next f of x plus h minus f of x. So instead of x, substitute x plus h, that will be x plus h whole power n minus x power n. So let us apply the standard first derivative f dash of x limit h tends to 0 f of x plus h minus f of x divided by h. So if I substitute here limit h tends to 0 x plus h whole power n minus x power n divided by, instead of x we can write this function that is h plus h minus x. If I cancel this again I will get this one. So this is in the format of the limit a tends to 0, x to the power of n minus a to the power of n by x minus a can be written as n into a to the power of n minus 1. N into a to the power of n minus 1. X tends to 0. So the same logic we can apply here. It is here x in place of x plus h is there, in place of a x is there. So n is as is. So if I apply the limit, it will become n. N in the sense n only n into a to the power a means x to the power of n minus 1. N minus 1. Therefore, we can say that d by dx derivative of x to the power of n can be written as n into x to the power of n minus 1. This is the derivative of the exponential function. Next, logarithmic function. Third one is logarithmic function. So the function is y is equal to log x will be how much? Okay, we are finding the derivative of it. So answer, let f of x is equal to log x. So next similarly x plus h minus f of x. F of x plus h in the sense here log of x plus h minus log x. We know that log a minus log b can be written as log a by b. So that is log of x plus h divided by x. So here we can split this in terms of like this. Log of x by x is 1 plus h by x. So let me apply the derivative of the first principle, that is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So that can be written as limit h tends to 0 log of 1 plus h by x divided by h. So we have one standard derivative and limit definition here. Limit x tends to 0. So limit alpha tends to 0 log of 1 plus alpha k divided by alpha is equal to k. So if you observe this, compared to these two limits, here you can see that x tends to 0, but instead of k we are having here 1 by x. We are having here 1 by x. So we can write directly the answer as 1 by x. So therefore we can write derivative d by dx of log x, answer is 1 by x. Next, let us see one trigonometric function. Fourth one, derivative of the trigonometric function. So y is equal to sin x. Let us find out the derivative of this sin by using the first principle. So answer, let f of x is equal to sin x f of x plus h minus f of x. So that is sin of x plus h minus sin x. So it is in the form of sin c minus sin d. Sin c minus sin d we can write it as 2 cos c plus d by 2 sin c minus d by 2. This can substitute in this formula. Then we are going to get as 2 cos c plus d by 2, cos of c plus d, that is x plus h 2x plus h by 2, sin of c minus d, so x gets cancelled, x by 2. So this is the value of f of x plus h. Let me apply the first principle. F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Limit h tends to 0 f of x plus h is 2 cos, this can be written as x plus h by 2 sin h by 2 divided by h. Divided by h. Now we know the formula that limit theta tends to 0 sin theta by theta is 1. So let us apply this. Now if you see here theta, it is h by 2, but here it is h. So whatever this 2 is there, you just bring it down. So it will become limit h tends to 0 sin h by 2 divided by h by 2. This 2 is coming down into cos of x plus h by 2. Cos of x plus h by 2. So this answer will be 1. So 1 into limit h tends to 0 cos of, we can write it as h by 2. So h by 2 tends to 0 cos of x plus h by 2. Okay. If I apply cos of x plus h by 2, in case of h by 2, if I put 0, it will going to be the answer as cos x. So derivative of the sin x is cos x. Now let us write the next function. So next function we will write directly formula. Let us see the simple one directly. So derivative d by dx of cos x, so we will get sin x minus sin x. Derivative of secant x, it will be secant x into tan x. D by dx, derivative of cosecant x minus cosecant x cot x. Derivative of cot x minus cosecant square x. Next, 9th one. Derivative of tan x secant square x. Derivative of inverse function, no? Sin inverse of x 1 by root of 1 minus x square. Derivative of cos inverse x, arc sin x also you can write. So cos inverse x is minus 1 by root of 1 minus x square. Next, derivative of tan inverse x 1 by 1 plus x square. Derivative of tan inverse cot inverse x minus 1 by 1 plus x square. Derivative of cosecant inverse x it is minus 1 by x into root of x square minus 1. So derivative of secant inverse x 1 by x root x square minus 1. So these are the various derivative formulas which we have to remember in order to solve the problems. Let us see the 10-point exercise first question. Find the derivative of the following functions with respect to the corresponding independent variable. So here the variable is x, so we need to do f dash of x. So let us see the answer. F of x is equal to x minus 3 sin x. So let us apply the derivative f dash of x is equal to, so here we can write it as d by dx of x minus 3 is the number constant, derivative d by dx of sin x. So for a constant function, already we learned that the constant function derivative will be 1 minus 3, sin x derivative is cos x. So the answer is 1 minus 3 cos x. Let us see the third question. F of x is equal to x sin x, you need to do the derivative with respect to x. F dash of x is equal to, so we can write it as d by dx of x sin x. So x is a different function, sin x is a different function. I will assume it as u, I will assume it as v. So we know that uv, so d by dx of uv, product rule, can be written as d by dx du by dx, or else we can write uv dash plus uv vu dash. So first function as it is, derivative of the second function plus second function as it is, derivative of the first function. So first function as it is, first function as it is. So next derivative of the second function, derivative of sin x plus second function as it is, derivative of the first function. First function is so x, derivative of sin x is cos x plus sin x, derivative of the constant function is 1. So answer is x cos x plus sin x. Next, fifth question. G of t is equal to t cube cos t. So let us do g dash of t derivative, that is d by dt. Why? Because the variable is t, I am using the t cube cos t. So here two different functions are there. One is exponential function and the other one is trigonometric function. So here it is u, v. So just now we have seen the product rule, d by dx of uv can be written as uv dash plus vu dash. So the first function as it is, that is first function is t cube. Next derivative of the second function, that is d by dt of cos t plus second function as it is cos t derivative of the first function t cube. So t cube into cos t, cos function derivative is sin minus sin. So answer is minus sin t plus cos function as it is. So derivative of the x power n derivative just now we have learned d by dx of x power n can be written as n into x power n minus 1. So here n value is 3 into t power 3 minus 1 which is 2. So if I rewrite it is minus t cube sin t plus 3t square cos t. This is the derivative. Next, seventh question. Y is equal to e power x sin x. So answer let us do derivative dy by dx dy by dx is equal to, given function is e power x sin x. Now it is in the format of uv product rule. So d by dx of uv is uv dash plus vu dash. So first function as it is e power x, derivative of sin x plus second function as it is sin x, derivative of e power x. So here e power x, derivative of sin x is cos x plus sin x, derivative of e power x is e power x. Derivative of e power x will be always e power x. So we can take this to e power x common. The left value is cos x plus sin x. Next, eighth question. Y is equal to tan x by x. Answer derivative. So let us do the derivation with respect to x. Dy by dx is equal to d by dx of tan x by x. So it is in the format of u by v. So let us apply the quotient rule. D by dx of u by v can be written as denominator function as it is derivative of the numerator function minus numerator function as it is derivative of the denominator function divided by denominator square. So let us apply this. First denominator as it is. So denominator here is x into derivative of the numerator. So d by dx of tan x minus numerator function as it is, that is tan x, derivative of denominator function, that is d by dx so d by dx of x divided by denominator square, so it is x square. So this can be written as x into derivative of tan x is secant square x minus tan x. So derivative of a constant function is 1 divided by x square. So we can write it as x secant square x minus tan x divided by x square. Next, let us see the ninth question. So we need to do derivative y is equal to sin x by 1 plus cos x. dy by dx is equal to d by dx of sin x by 1 plus cos x. So it is in the format of u by v. So quotient rule we are applying. That is d by dx of u by v is equal to v u dash minus u v dash divided by v square. So first denominator function as it is, that is 1 plus cos x into u dash derivative of d by dx of sin x minus numerator as it is sin x into derivative d by dx of 1 plus cos x divided by v square. So 1 plus cos x whole square. So next step, 1 plus cos x. Derivative of sin x is cos x minus sin x. So derivative we have to apply 2 times here since it is a sum rule. So derivative of the constant function is 0 plus derivative of the cos x is minus sin x. So divided by 1 plus cos x whole square. So we can rewrite it as cos x into 1 will be cos x plus cos square x. So minus into minus plus sin square x divided by 1 plus cos x whole square. So identity is sin square x plus cos square x is 1. So the answer is cos x plus 1 divided by 1 plus cos x whole square. So these will be just one time cancel. So we are left with 1 by 1 plus cos x. This is the derivative. Let us see the 10th question. Y is equal to x by tan x plus cos x. So we need to do the differentiation with respect to x. So dy by dx is equal to d by dx of x by sin x plus cos x. So it is the quotient rule u by v. So same derivative we have to use d by dx of u by v is v u dash minus u v dash divided by v square. So that is equal to first denominator function as it is sin x plus cos x derivative of x minus x into derivative of d by dx of d by dx of sin x plus cos x divided by v square, that is sin x plus cos x whole square. Next step, sin x plus cos x, derivative of x is 1 minus x into, so derivative, here common rule we have to use derivative of the first function plus derivative of the second function. Derivative of sin x, we know that it is cos x, and derivative of the cos x, we know that it is minus sin x, divided by sin x plus cos x whole square. So this is sin x plus cos x minus x cos x plus x sin x. Sin x plus cos x whole square. So in these two we can take x sin x common. If I take common sin x, I will be left with 1 plus x. So plus, in this I can take cos x common. So we are left with 1 minus x divided by sin x plus cos x whole square. So this is the